Let's use what we know about transformations to write the equation of graphs that have been transformed. So we're going to begin with a parent function, and it may be the square root of x, it may be the absolute value of x. What we learned is that it doesn't matter, all our transformations will have the same effect no matter what kind of function family we're looking at. So the first thing they want me to do is shift the graph right 6 units. Well, I recall that that's going to occur inside of the radical, or the parentheses or absolute value bars, and I do the opposite of what it says. So if I want to move right 6, what I need to do is actually subtract 6 to do that. So my first step would look like this, the square root of x minus 6. After that, they want me to then shift the graph up 4 units. Well, I recall that vertical shifts happened outside of the radical or parentheses, and they did what they said they were supposed to do. So to shift up 4, I'll have a plus 4 at the end of this. Don't forget to throw your y equals or f of x equals in front to turn it into a function, and there's going to be the equation that has these transformations on it. Okay, let's go ahead and try this one at the bottom. This time, I've got a horizontal compression. Well, once again, horizontal things will occur inside of the parentheses or radical, or in this case, inside of the absolute value bars for this parent function. So I remember I know I'm going to be inside. I also remember if I'm inside, I need to do the opposite, or in this case, the reciprocal, to have this effect. So if I want to horizontally compress by a factor of a half, I actually need to multiply by 2, the reciprocal of 1/2. Next up, then, they want me to vertically stretch this by a factor of 3. Well, vertical things happen outside of the bars, and they do what they say they're going to do. So if I want this to be stretched 3 times taller, I'll multiply the outside by 3, and then the absolute value of 2x. And no, you cannot multiply those to make 6x. And then once again, to finish it, just go ahead and throw a y equals or an f of x equals in front, and there's our function that's been translated as transformed as they've described. We'll do something very similar when I'm dealing with reflections, but watch in these two examples how I have to be really careful about what I'm making negative. I remember that reflection meant make something negative, and watch how that's going to be a little bit different with these. So once again, let's kind of go down the steps and just see what happens. So to shift my graph down 5 spaces, that vertical motion will happen outside of the parentheses or radical in this case, and it's going to do what it says. So square root of x and then a minus 5. Next up, I want to move left 4 units. Well, a horizontal shift will occur inside of the radical, and it's going to do the opposite of what it says. So if I want to move left 4, I actually need to add 4 to what I have. So my next step would look like this, the square root of x plus 4, and then minus 5. And now finally I have to deal with this reflection. And because I want to flip over the x-axis, what I need to do is make the whole function, or everything outside, negative. So I want to take everything outside, or the entire function, which we now have as x plus 4, the square root of x plus 4 minus 5. And since I want to show everything is going to be negative, I'm going to put the whole thing in parentheses and include that negative out front. Now what I probably want to do is I want to drop the parentheses. So in other words, I'll need to distribute that exponent. So it'll affect everything outside. My final answer will have a negative out front, so negative, and then square root of x plus 4. That plus 4 is inside the radical, and so that's unaffected. But then that minus 5 will change signs and actually become a plus 5. And if you think about why this might occur, if you imagine a graph and what would happen in a reflection, if I have a graph, or let's just say a point, that's been moved down 5 spaces, so maybe I'm somewhere down here, but then I reflect it over the x-axis, look where it ends up. It actually ends up being up 5. So here is going to be my function. I'll throw the y equals or f of x equals, but that's what we want to watch out for. If I'm reflecting the entire function, I have to make sure I change a couple signs with this, okay? And then let's finish with one more example, this time involving a reflection over the y-axis. Something very similar will happen this time. First up, I want to vertically compress, so this will occur outside, and it'll do what it says it's going to do. So 1/2 times the absolute value of x. Next up, I want to shift right 2 units. Well, if I want to go right 2, I need to do the opposite of what it says. Horizontal shifts are always opposite of what they say, so I'll actually subtract 2 to move to the right 2. And then finally, I want to reflect over the y-axis. Well, to reflect over the y-axis, I need to make the x, or everything inside the bars, opposite. So my final step may look something like this. And once again, since there's more than one thing inside the bars, I can't just say negative x. I've got to say opposite or negative of x minus 2. So I need to, again, distribute that negative to everything inside to perform a reflection over the y-axis. So my final answer, once I do that, may look like this. The absolute value, or 1/2 times the absolute value of negative x, now plus 2, plus 2. And then once again, I'll throw my f of x or y equals in front, and there we have our transformed equation.